Okay, so this is our helper video for chapter 12, which deals with pricing and advertising. Um, in this chapter as a whole, we're dealing with firms that aren't going to charge a single price. They don't necessarily have to be monopolists, but monopolists are able to engage in some more interesting pricing, um, well, certainly than perfectly competitive firms, but even really anything that's not perfectly competitive can engage in this kind of price discrimination, which is what we're talking about for most of this chapter. So let's start with number one. Number one is kind of a definitional question. And what is it? Essentially, it's asking, what does it mean to be a price discriminator? Okay, so the ideas are, and I'm just going to talk about this in general, and then we'll talk about what the answer is. The idea is that you have different customers who have obviously different willingnesses to pay. Um, that you have some ability to stop reselling between the customers. Actually, that's actually don't think I need to add anything more. Actually, I'm actually pretty comfortable with that. Because that is essentially what it means to price discriminate. Now let's apply it to this question here. What does it mean when we say we have different customers? And why would they have a different willingness to pay? Well, the reason why they're different is because they have different elasticities. Right? If we, talk about someone who's a on this date once where she wanted to go see the Harry Potter movie. I don't even know which one it is. Not only have I not watched any of the movies, I haven't even read any of the books. I understand it's the concept of that guy flying around and stuff, but I don't know anything about it. She wanted to see it opening day. Dude, they were like weirdos at the theater, like right dressed like whatever the characters are in the movie, and I didn't really care. Now, if you were asking how much would you be willing to pay to go see that movie, I'd be like, dude, I don't even want to see it, so nothing. Right? Whereas practically everyone else would probably pay 10, 20, 30, $40. Um, and so why wouldn't a movie theater try to get at that? Now, they can't ask each person how much they're willing to pay, but it could say, hey, if you're seeing this movie on opening day, you're going to pay more than a person who sees it 1 month from now. Or if you're going to see it in the middle of the day on a Tuesday, then clearly you've got less money than a person who wants to see it on Friday night after having worked all week. Okay, so as we start to think about all these things, all these options here, is it that the customers have different price elasticities? Yes. Um, are they? Are we able to identify different types of customers? Yeah. And are we able to prevent or limit resales? Yeah. So at least right now, A is a contender. The ability to set its price and the ability to identify each customer's willingness to pay. Well, that's only one part of it, right? This idea of different customers. The ability to set the price. Consumers have these different price elasticities, and the ability to prevent or limit resales. Um, yeah, but how is this? Sorry, I just need to read the ability to set the price. The ability. Yeah. So, sorry, this is just highlighting the problem with A and C. A and C look rather similar, and obviously, I'm just kind of looking at this for the first time. I don't know. I think it makes the homework more exciting to kind of see my thought process. So there is a difference between A and C. Originally, I said A looks like it's a contender. When I got to C, I realized A is no longer a contender. Why? Because A is implying A could be true even for a perfectly competitive firm. um, you need to have some pricing power be present. So let's add this as a condition over here. It was kind of implied. I kind of assumed that to be true. So you would have an ability to set the price. Okay. And then let's compare this one to this one. The ability to set the price, consumers with different price elasticities, ability to identify different customers, and the ability to limit resales. Um, so what's different between C and D now? Ability to set the price, consumers with different price elasticities, ability to prevent or limit resales. Well, yeah, I guess you would need to know your different kind of customers. So, yeah, the answer is D. Sorry, I kept A looked good. I mean, in essence, basically A, B, and C are good, but they're partial answers. I guess in this sense, it is all four of these conditions. Um, I'm not, I'll be honest, I'm not too sure um, the second and the third condition are kind of. uh, How could you do the second? How could you identify? How would you even know that consumers have different price elasticities if you weren't able to identify that you had different kinds of customers? Doesn't knowing this imply that you already know this? Whatever. Okay, fine. You're not going to see a question like this on the exam or on the problem set. As long as you understand these are the four conditions, let's just leave it at that. Which of the following conditions must be true so that a firm can price discriminate? That the good is non-durable. It doesn't really matter. It could be durable or non-durable. Me watching that movie is a non-durable good, but we could imagine that we charge higher prices to consumers for um, durable good. I mean, there's nothing that would stop people from buying a durable good in this kind of way. So, no. The good cannot be easily resold. Yeah, that would have to be true. So let's just go on here. There are no other firms in the market. That's not true. So, as you remember, as my kind of lead up to this, as long as you're not perfectly competitive, you can engage in some price discrimination. So it's not just monopolies. So C is not an option. And then obviously D is not an option. So the correct answer here is B. Which of the following is not an example of price discrimination? Charging women more than men for an identical haircut. Okay, so the key thing here would be the idea that it's the exact same haircut. And you're just charging women more because maybe women care more about their hair than men, or are more willing to pay, are willing to pay more for that haircut. So if it's the exact identical product delivered and it's just that women pay more, that is the essence of price discrimination. Charging children less for a ticket to the movies. Again, that would be price discrimination because it's the exact same movie that everyone gets to watch. It's just that children either have no choice or they don't have as much money. And so as a result, um, because they don't really have a ton of choices or a ton of concern and they have no money, then they'd be more elastic with respect to the price. Senior citizen discounts, same as the child discount in B. It's the idea that um, they could be getting the exact same product as adults, but they pay less because presumably they have less income or right or something along those lines. Charging young men more than young women for auto insurance. That is the correct answer. Why is that the correct answer? Because, dude, young men especially, drive badly. I don't know why there's always this like classic notion of women drivers and saying that they're really bad drivers. No, dude, young men, speed, 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 and reckless with respect to stop signs. Actually, Again, I haven't had any bad interactions with a young kid. No, I should take that back. I did get someone once hit the bumper on my car, and it was a young guy, and he was looking at his phone. So there, that's even reason enough. But here, the idea, the reason why this is not an example of price discrimination is that young men are more dangerous drivers than young women. And so, actuarially speaking, we should charge them more because they're more likely to generate claims for the insurance company. So we charge them more. Okay. Now we've got affirmed that the natural monopoly, the marginal cost curve is flat, and its average cost curve is downward sloping. The firm can perfectly price discriminate. That would mean, again, charging a different price for every customer. How much will this monopoly produce to maximize its profit? Well, if that's the case, where perfectly price discriminates, then the marginal revenue is demand. Meaning, because it's a first degree price discriminator. And what do? We set MR equal to MC. Okay, so here's my MC, here's my MR. Enters Q4. I'm not sure what more I need to say about this. But again, this question would be difficult if you didn't see that or read closely enough that last line. Because they are perfect price discriminators, the marginal revenue is the demand. If they were a single price monopolist, then this would be the MR curve, and the quantity would be Q2. But that's not the case here. Sorry. No, I got it. Okay, number 5. So here we have a movie theater trying to decide between doing some degree of second degree price discrimination, meaning charging college students different prices than senior citizens than others. Okay, what change to the table would you make? What change to the table would make profit from charging a single price greater than profit from perfectly price discriminating? Just eyeballing this here. Sorry, I'm just. Just. I don't see any. In all of the situations, yeah, total profit. Yeah, total profit. Yeah, they're the correct. I'll at least tell you the answer here first, and then we'll talk about why that's the case. So, what was I looking at here? Well, I was trying to look at different scenarios here, but the easiest one would just be is that you look at this column and this column. If they charged everyone $6 or they charged everyone $12 as a single price, these would be the relevant total profits. With the total profit in this case, right, in both of these cases, that would be less than $300. And same here, right? For more college students, fewer senior citizens still. Every scenario, the $6 and a $12 uniform price. But also, even here, the best case scenario is that even if you perfectly price discriminate, you could possibly make the same amount as charging a uniform price for one particular group. But in no case are you better off charging a single price, even for a single group. So then you might ask yourself, It just goes beyond the homework question. Why don't all firms then just price discriminate? Again, the answer for that is that it's very expensive to determine what each customer is willing to pay. And then the second part of this question, what changes to the table would increase the extra profit from perfectly priced discriminating? So really the only Okay, let's just go through these here. I was just trying to think of it theoretically here, but let's just go through these. The extra profit from perfect price discrimination would increase. Well, no, that's just the definition of the idea is that they have to have the same marginal cost because um, it's the same product, so it doesn't really even your profits aren't going to change at all. And we're talking about profit is different than your difference between price and marginal cost. Would increase if there were an equal number of college students and seniors. No, I don't really. It's not really going to have an effect at all either. Would increase if college students and seniors were willing to pay. Well, no, it can't be C because if it were C, then you wouldn't price discriminate at all. You would just charge a uniform price if they had the exact same willingness to pay. Would increase if the marginal cost were greater than zero. No, I mean, your marginal profit, not the same as your profit, but your marginal profit would then even be smaller. So we're only left with E, but let's also just talk about why um, that's the case. Well, I guess I mean it you kind of get it from this definition here, but the idea is that um, senior citizens are willing to pay up to six, but if you put down $6 price, you're losing some senior citizens that would have been willing to pay five, four, three, and same for college students. College students don't want to be charged any more than 12, but you could go 11, 10, 9. And so the idea here is that you could possibly find some ways to discriminate, to change the reservation prices even more by having them come at different times of day, for instance, or even just trying to say, do you go to community college versus a private university where maybe they're richer, right? Whereas community college seems to be poor. Right? Or senior citizens, do you live on just Social Security or do you get a big old fat pension? So there'd be other ways to, if you could charge even very different reservation prices, you could actually increase your profit even more. Okay. Now we've got a monopoly with it, and we've got our um, inverse demand function. Okay. Constant marginal cost of 90. So we got marginal cost of 90. And again, this is my question that was presented to me. Yours may be different. Okay, so what's the profit from perfectly priced discriminating? Well, what we need to find is MR equals MC. Because this firm is perfectly price discriminating, this is also my marginal revenue. So 270 minus Q is actually equal to marginal revenue because they are perfectly price discriminating. So 270 minus Q is equal to 90. Negative Q equals negative 360. Q equals 360. No, we can't have a negative. Where did we make a mistake here? Oh, duh. Sorry. Math mistake, math mistake. Yeah, that's just how comfortable I am with you all. We're getting towards the end of the semester, and maybe I'm becoming nostalgic, or we've got senioritis here, where we all say, "Well, keep in touch," and all those kinds of nice things. But no, sorry, because obviously 90 minus 270 is negative 90. I'm sorry, but ah, negative 180. Then what can I do? I'm going to take my total revenue, it's just my P times my Q, which would be 90 times 180, which gives me a total revenue of 16,200. Um, Average cost is 90. And so what do we do here? So now what we need to solve for here. So the total costs. So what's this saying here? This is average total cost times quantity. We are. What am I forgetting to do? Sorry, we're forgetting something. Because there is some profit here. I'm just forgetting to do something. Let me pause this while I try to find my math error. I made a math error somewhere. Oh, I'm actually all good. Sorry, I was just second guessing myself, feeling self conscious about my math abilities. If one of you were here right now, you could pat me on the back and say, Shiding, you're not so bad. You would make me feel good about myself. So I'm drawing a little picture here for you. We to calculate what's going on here. We need to calculate the profit, and they're perfectly price discriminating. We need to solve the area of this triangle. We already know that the consumer surplus is zero by definition in perfectly price discrimination. We need to find the y-intercept of the demand curve. That would be where the quantity is zero. This would be 270. Now we got everything we need. The area of this triangle is going to be 1/2 base times height, which is going to be 1/2 times 270 minus 90 times 180, which is just 1/2 180 times 180. And I get a total profit of 16,200. And then what is the total welfare? The welfare is going to be now just this lower triangle here. Um, which you're going to need to calculate. No, we don't actually really need to calculate it. It's going to be the same as what we had here, since the marginal cost is the same. So it's going to still be our 16,200. Deadweight loss, by definition, is still zero. That's again a good reason why we have these kinds of firms. Now, what happens? How does this all change if we go to a single price monopolist? Well, now things change. So now, let's just change the color of what we're working with here. So now marginal revenue is twice as steep. So now 270 minus 2Q is equal to 90. Negative 2Q is equal to negative 180. Q is equal to 90. P is equal to 180. $90 times 180 is going to give us our total revenue. And so our total revenue here is going to still be back to the 16,200. But our problem here, I guess the best way to put this here, is that so now they're just charging the same price of $90. In terms of the profit for the single price monopolist, now our picture looks a bit different here. We've got a demand curve here. We've got a marginal revenue curve here. We've got a marginal cost curve here. Got a 90 quantity there. And it gets me a 180 price over here. And we still have our $90 right here. So now what you can see here is you're going to have to solve the area for that profit right here. That I've got a difference of 90, which is the difference between 180 and 90. And then I'm multiplying it by my 90 here. So that'd be 1/2 90 times 90. 1 second here. Okay, sorry. Where was I? Oh, okay. So we need to solve for this square right here, which would just be the difference between that 90 times that 90 right here. Right, so it'd be 90 times 90, which would give us the profit. The consumer surplus is going to be this remaining triangle right here, which you'd have to find the y-intercept. The deadweight loss is going to be this triangle here, so you're going to have to, we already know that quantity, that's 180, because that's from over here. So now it'd be 1/2 90, and now we have to find this distance here. So the top of this would be the 180. Put in that quantity of 180 into the marginal revenue curve, right? Yeah, sorry, here. Right here. And you'll be able to find the the y for right here, and that will give you 1/2 base times height for those triangles. Okay. Number 7. Again, I'm just trying to give you strategies here to solve it. If you're getting really frustrated with your particular numbers, there will be, again, your moment when you email me and say, hey, Scheiding, this is the number I'm presented with. Can you help me work through this here? Happy to do that. Okay. Nora Jones. Oh, God. I really don't like her. Okay, Nora Jones. Feels Like Home from 2005. I kind of even vaguely remember that album. Okay, so you're going to have to. Okay. So I'm not sure, what's it having you do? Label this curve MC. Well, MC is on the horizontal axis, so the horizontal, so this would be the MC is right here. Okay. Well, the consequence of that would then be is what's it asking you to do here? Okay, so that's that. And we also have to label the producer surplus. Well, all of this whole thing would be producer surplus, so that's your answer for right there. The drawing out the marginal cost, that's what I did for you right there. And then we're asked, if the monopoly can charge a single market price, does the concert's failure to sell out prove that the monopoly set the price too high? That the concert does not sell out, what does it do? Does it indicate or does it not indicate that the price is too high? It doesn't really. I mean, because again, remember, monopolists face an incentive to create a deadweight loss that allows them to charge the higher price. So that's the very definition of what single price monopolists do. They make more money by restricting quantity. We as a society don't like it, not only because we're making people pay more, but because there's a deadweight loss. That deadweight loss height of that triangle is created as the quantity is reduced. Okay, number 8. So a monopoly sells its good in the US and Japanese markets. So again, here's the idea. 2 different kinds of customers, Japanese and American. And as we see here, 2 different inverse demand functions. Now, same marginal cost though. $15. So, dude, this problem is so easy. All we need to do here. Oh, fuck, how did I do that? Where did all this come from? Kidding me, right? Oh, I was getting all excited to solve this, and now I can't even erase this. Are you kidding me? I'm sorry. I was getting all excited to solve. I don't even know what I did. I'm not going to bother. I still have my excitement. I like these kinds of questions. Now, you do see a variation of this on the problem set. Oh, go figure. Scheiding made the problem set and he loves these kinds of problems. Why do I like these kinds of problems? Well, because this is a pretty common thing that many of you would experience if you go out into the working world just armed with your economics degree. This is the kind of stuff that economists do. We identify that there's 2 different markets. We find the price or we find out what the inverse demand functions look like, and we go from there. Marginal cost commonly is 15, and this is the one in the problem set that's the bottled water, I think. So I'm just labeling US as A, and then Japanese will be J. I'm just going to keep it easy and make it J and make it B. Okay, so then 120 minus 2QA equals 15. Negative 2QA equals negative 105. QA equals right, and so we're just solving this. Now, the price, which is what we're being asked for here, means that I now need to take these quantities and put them back into the functions. So for America, it would be 120 now minus 52.5 equals P. Yes, I'm doing it in the calculator only because I don't want to make a mistake here. The price is equal to 67.5, and in Japan it would be P equals 100 minus 2Q. That would be 100 minus 2 times 26.25. P equals 47.5. There we go. Okay, number 9. Again, your numbers are going to be a little bit different depending on what you get. Okay. Monopoly sells its good in the US where elasticity of demand is negative 2.3, and in Japan where the elasticity of demand is negative 5.9, marginal cost is 9. At what price does the monopoly sell its good in each country if resales are impossible? Okay, so the idea here for number 9 is that we need to set this up with our elasticity. My wife is calling in 1 second. Okay, so what we're doing here, so we're again using algebra here. So we know that the elasticity of demand for the US is negative 2.3. That the elasticity of Japan is negative 5.9, and that they have a common marginal cost of 9. Well, then what we do here is we use, we're going to have to do this for each country. But we're going to take the elasticity of demand in each individual country, and it's going to equal the price, which is the thing we're solving for, over the marginal cost minus the price. We know the elasticity, and we know the marginal cost, and we're going to solve for P. So let's just start with the first one here of the US. So we have negative 2.3. I'm just going to call it X because essentially it's what we're solving for here. 9 minus X. Okay, so then, here's a calculator. So I just multiplied 9 minus X times negative 2.3, so I got negative 20.7 plus, because it's minus times minus, plus 2.3x equals x. Negative 20.7 equals negative 1.3x. Negative 20.7 divided by negative 1.3 is 15.92. Okay, so they must be charging about 15.92. And then in Japan, now it's going to be negative 5.9 equals x over 9 minus x, because the marginal cost is the same. So it'd be negative 53.1 plus 5.9x equals x. And then I'm going to divide each side by 4.9, negative 4.9. And I get a price of 1084 rounded. So I get a price here of 1084. You do have a similar problem to this also on the problem set. So these two are pretty important. You will see these again. Okay, number 10. Two identifiable markets differ with respect to price elasticity demand and resale is impossible. What will the firm with market power do? Well, they're going to, this is in some sense definitional. And where customers are more price elastic, meaning they're more sensitive to the price, I'm going to give them a lower price because I want to get them as a customer. And we see that here, right? In Japan, the customers were more price elastic, negative 5.9. They got charged a lower price. Okay. Number 11. Here in number 11, the firm, quantity discriminating monopoly, 3 different prices depending on the customer, and here's its profit. What is it going to set its price at? The marginal cost is 10. My example here. And we've got a demand curve right here. And we need to find the 3 prices. So again, we're, as you kind of see here in the kind of the discussion here, is that we are basically going to charge a different price for each block of production. Okay, so we don't, in the problem set, nor in the exam, do I really have you doing this. I'm trying to debate about what. I actually don't really. Okay, I'm going to make a note here to myself. I don't want you to worry about this one. We're not doing anything like this for the problem set nor for the exam. The only thing that you're kind of tested on is this general idea that the larger a block of product you're willing to buy, the quantity discount, the lower the price you should pay. You're not going to see this again, though. So I'm going to go back into the problem, the homework, and I will cross this one out so you can disregard this one. Okay, let's go on to number 12. So now we've got the block pricing here, and the question that's asked of us is where would they capture basically all of the um, where would they capture all of the consumers? So for us here, we want them to choose a price for the first block such that consumers that are willing to buy 50 units. Okay. Um, and so, what is the first block price? Well, in essence, we're not going to see. Oh, 1 second. Sorry, my wife's calling one more time. Okay, so where was it with this? Oh, sorry. Okay, so we were saying we want them to buy at least that we want them to buy 50 units, but we want them to capture all of the potential surplus and no deadweight loss. Well, dude, there's only one way to do that. That last part. The only way that they can have no deadweight loss, all producer surplus, and then presumably no consumer surplus, would be to charge that $90 price, because then they would capture the whole thing. Um, I mean, they obviously, as part of it, they would also um, they'd also sell those 50 units. Okay, if a monopoly charges the higher price to consumers who buy smaller quantities than consumers who buy larger quantities, then what is true? Well, there would be some consumer surplus that would exist. It would just exist in kind of smaller areas, right? Because you'd have presumably one demand curve that looks like this, let's say, and one that maybe looks like this, right? For different kinds of customers, same marginal costs, and you would have different prices with smaller triangles, but multiple. Social welfare larger? No, because it's the largest under competition. Profits are larger than single price? No, because the deadweight loss is larger under a single price. Profits are larger than under perfect price discrimination? No, you get the most profit with perfect price discrimination. So A is the only possible option. Explain why charging a higher or lower price than P equals 10. Show the monopoly profit if profit price equals 60, profit P equals 10. Okay. So what does that mean for us here? That if I charge a price higher than 10, what will happen? Why would my profit be reduced? And it actually doesn't matter which number you're getting. Mine says 10, but actually in this case, it doesn't matter what number they gave you, at least so far. The reason why the profit is less is because I don't make as much. So that's just definitional. Charging a price lower than 10. Why is the profit going on? Why is the profit going down? Well, the reason now is because I'm making too much. So I'm making units that are not as profitable. Then the question is, what is my profit? In this case, what is my profit when the price is 10? And then what is my profit when the price is 60? Well, my profit here is just going to be my difference again between my revenue and my cost. So My marginal cost here is 10. Oh, now my son's calling. One sec. Sorry again for all these interruptions. Going back to this. So we've got the two-part tariff when the price is 10 and the price is 60. So the idea here with each of these is that for the two-part tariff, you're charging a price that's essentially equal to your, in the first part, you're charging the price that's equal to your marginal cost. But then your second part to it is that you're capturing all of the consumer surplus with the other part of your tariff. So the profit for both of these cases is going to be this entire consumer surplus, or 1/2 base times the height. So you're going to solve, in this case, for when it's 10, and then you're going to solve for a smaller triangle for when it's 60. Well, for me, yours are going to be different, so that's why I'm not trying to keep this video so much shorter. It's already at 50 minutes. But you're going to solve basically two triangles, and those are going to be your profits. Okay, suppose a firm faces an identical inverse demand curve of P equals 140 minus Q. Firm's marginal cost is 40. Determine what the price, what prices should be charged. Okay, so what did I just say? What did I just finish saying here? This price here is going to be the same as my marginal cost, whatever is presented to you. So in my case, it's 40. So I charge that as my first, right? I charge my average cost. Then the lump sum fee, that's where I'm getting all of my consumer surplus. So I'm going to need to solve for that. Okay. Okay, so we need to solve for this. And I need to solve for this. And then I need to find the whole amount. Okay, so this would be 140, right? Because it would be 140 minus 0, so that's 100. Then I'm going to put in a $40 price, so 40 equals 140 E minus Q. That would be negative 100 equals negative Q, or Q equals 100. My wife is calling. Okay, I did tell my wife to stop calling so much, but I doubt that that's going to happen. Anyway, I did solve this though while she was talking to me. My lump sum fee, which again I'm solving for this whole triangle here. There's my math right there. So just solve it with your 1/2 base times height. General thing there. Okay, let's go on to number 16. Two types of customers, and we're going to be bundling. Okay, so then we're solving for the profit levels with these different bundles. And, okay, so 150, 140, 140, 130, 55, 30. Profit from selling the goods at different prices. Okay. So what would be my profit at selling them at different prices? Let's see. 90 to 10. Okay, so marginal costs are virtually 0, so that will figure into our profit levels here. So if the profit maximizing price here is 140, I'm going to get this customer here. Sorry, not this customer right here. And if I charge a price of 130, or sorry, not a price of 130, but if my profit maximizing price is 130, I'm only going to get this customer right here because that's what they were willing to pay, right? So customer one was willing to pay for the internet $150. If my price is $140, then they will buy it. Additionally, if the price is $140, customer two will also buy it now. So what do we get here is our difference here. You get a 150, 140. I get a 290. Yeah, so that would be my profit from selling them at separate prices, right? I would get all that profit from the first customer who valued it at 150 and from 140. Yeah, and then their difference between these two groups, 130, 130, there being no difference between that group. Now, the difference emerges though when I do the bundling. So when I do the bundling, the idea here is that the customers are going to be able to, I'm going to offer slightly different prices to try to get, in this case, especially customer two, who isn't getting the television, to start to get the television with me. But the problem that's going to emerge is that the bundle, and you can't see it because I've kind of written over it here. This is the eraser, isn't it? Is it erasing? Oh, come on. There we go. Okay. But the idea is that although I will get additional customers by bundling the goods, I have to offer a slightly lower price. And so we see that here. Whereas if I charge $270 for both of them, right? Instead, they're only going to be charging $195. So that's obviously going to cause a problem for me. So okay, let's go back to this here to solve this out here. Okay, so if my profit maximizing price is 140 and 130 for individual customers, who's buying the internet? Customer number one is, and customer number two is. TV, if I charge a price of 130, only customer number one. Okay. So that would be 280 in total revenue from the internet, 130 in total revenue from TV. So my profit here would be a total of 410. Now, in terms of the bundled price at 195, I get both of these customers here. So the idea should be, right, that you should get a bit more um, profit, at least, when you do bundle goods together. At least you do in this case here. Um, Wait, I made a mistake here. Sorry. It's not 280. Sorry, it's 150 and 140, which is 290. 290, and then making sure I'm all good here, 130. 300, 420. So it should be 420 instead. Which is tomorrow. And yeah, my math is still okay with 280 and 195. Okay. Now, for the mixed bundling, the idea here would be is you would offer customers the option um, to either buy things individually or not. In this case here, with the prices I'm being um, presented, you wouldn't use any mixed bundling. Um, uh, the reason why you wouldn't use any mixed bundling is because in this case you have the price low enough, no one would buy things individually, um, right? That they, at least with the prices I was presented, there'd be no incentive to do it otherwise. Okay, so this is our 475 that came from here. And then the profit from selling at the profit maximizing separate prices and at the profit maximizing bundled price. Again, the mixed bundling, in this case, I wouldn't do it, right? I would just keep to, if I have both options, I'm just going to bundle things. So I'm just going to stick to my 475. So in essence, it gets to why don't we use this? Why don't firms then use the mixed bundling? Again, if we go back to this idea of what if I did um, separate pricing, I get both customers here. And if I charge 90, I actually will get both customers here. So I'll get 150, 90, 90, 150, which should be 480. Selling goods at the bundled price, it'd be 240 and 240, which is the same, 480. And so in this case, the profit from selling goods at either the profit maximizing separate prices or the bundled prices, well, doesn't take market sciences here, would still be my 480. Okay. Bundling sales. So this is just definitional, and this would be when they are negatively correlated. This is when it makes sense because you're trying to, um, if they were positively correlated, the fact that they bought one would make them more inclined to buy the other. You want to do it where they're negatively correlated and basically incentivize that person to buy it otherwise. Number 18, why would this firm not want to spend on spend A on advertising? Um, in this case here, sorry, I'm just trying to read this graph here. It doesn't actually look very clear to me. I actually can't see it here. I think this is just because of the way mine is drawn here. Sorry, all these are just too close together. Okay, I'm going to skip it for right now. Okay, let's just get on to number 19 here. What is the profit maximizing amount of advertising? Well, this would be essentially where the benefit is equal, marginal benefit is equal to the cost. It's just by definition of being a good economist. At least you followed a hard one with an easier one. Okay, each week, department store places a different item of clothing on sale. Which of the following is an explanation based on price discrimination for these sales? Okay, so, well, this would certainly be true, right? Because people that want it first will buy it first. They have the highest reservation price, and then lower would be later. Attempts to sell the firm with relatively elastic demand first. Well, no, they wouldn't buy it because the price is higher, so it can't be that. So with relatively inelastic demand first and then relatively elastic. Yeah, that's true. Okay, there we go. There's our A and C. Yeah, so the difference there is that they wouldn't, elastic customers wouldn't be willing to pay that very high price. Number 21, we've got estimations of our inverse demand functions in the United States and Europe and marginal cost. Oh, geez, you want me to solve this? Okay, I'm going to let you solve it. We've already gone through how to solve this. I'm just trying because I'm trying to keep the video a normal length here. And same for this. This would just be the bundled one we just did. So if you're having big, I'm not trying to shortchange you though. If you're having big problems with 21 and 22, this would be where you reach out to me. We can do a quick Zoom, or you can just show me your problem and I'll make you a video that walks you through it. But 21 and 22 should be similar to what we just solved for with two different markets and with